Okay, so hi everyone. Good afternoon. I believe, guys, I'm audible and visible to all of you. Please confirm. Okay, everyone. So good afternoon in a new timing. So we are meeting second time in this week. Okay, so let's do one thing, guys. Let me share my screen and let's get started with the class. So in my last class, I was talking about an agent, and we have discussed about technically a five agent, right? And I have listed down like a 10 agents, which is very very important, by the way. So till reflection agent we were able to discuss simple tool agent, reactive agent, then routing agent, a planning agent, reflection agent, and we were able to even trace the agent by using a lang smith. We were able to see how things are actually working in a backend, and how agent is actually behaving and is working. So we were able to prove all of those things. Now it's time for this particular part. So where we are going to understand another five agent, which is again very, very important because whenever you will try to build any application, obviously you all are going to use these agents. So let's do it, guys. Yeah. So here, let me create another Jupyter notebook file, and let me name it as five another agent. Then tomorrow we will try to look into evals basically. So how we are going to basically do a evaluation of the agent, because now we are creating an agent, right? But how good my agent is, how I will be able to restrict, or maybe how I will be able to evaluate my agent. So all of these things I'll be talking about again, because even that part is very very important, because without that you can't send any agent to a production. At the end of the day, it's a machine which is taking a decision, right? So obviously you have to keep a lot of checks on top of that, and evals is one of those checks. And even in rag and agentic rag, whenever I'm going to talk about, so I'll be talking about evals with respect to rag and agentic rag. So here, let's do one thing. So a couple of things we can copy from there itself. So first of all, we can copy this particular portion, select kernel. So it was 3.14. All the libraries are already installed. Fine. So this, and we can copy basically this one. We can copy this import from here. It is going to fail because key is not there. No, it's not. It has not failed. Then this. Yeah, I think we have done all the imports. So now we are good to start with the agent. So before that, I have to log in into my Langsmith, and then I can try to set my key plus my Open API key, which I have removed. So Google Langsmith, let's go there, and let me create my key for Langsmith. Tracing. Okay, so this was the one, but yeah, let's create a new key this time. API key, uh, agents. Okay, so copied, and I can keep my API key here for Langsmith. And similarly, I can go and I can try to create a key for basically OpenAI. Login, API platform, API key, test, copy, and then let's paste it here. So fine, guys, only this much is required. Apart from that, so everything we have already set in my previous class. So shall we start, guys, with another five agents? Yes, are we good to start? I believe we all are able to set it. Same thing last time that we have discussed. So first of all, I'll be talking about like a memory agent. Then I'll be talking about HITL agent, basically human in the loop, and then multi-agent supervisor, handoff agent, and a autonomous agent. So in this sequence, I'm going to move the sequence which is written over here. Yeah. So let's start it, guys. Execute, execute, execute. Yeah. Okay. So here, the very first one that we have to discuss is a memory agent. What is the meaning of this, by the way? Anyone in a class quickly? What is the meaning of this memory agent? I believe we all understands, but yeah, I'm just trying to understand that what in all kind of a memory exists and what it is going to do. I mean, like, what is the objective of using a memory agent? That's what I'm like trying to ask. Yeah. So anyone? Rishabh is saying that understand a previous message. Okay, fine. Yes. Any other understanding context wise? Yes. Retrieve memory and update memory, current previous, okay, fine. So I was saying, and then Kaj is saying current previous message context, fine. Viresh is saying answering based on the previous conversation. Yeah, so all of you are correct, by the way. So this is the meaning of a memory. So whenever you will go and chat to a chat GPT, you must be able to see that whatever like conversation that you have done, so it remembers, right? It knows your identity even when you will start doing a coding with respect to uh, you know like a Claude or maybe a Codex or any kind of a agent. So even over there, you will be able to see a memory part, so that every time it is not supposed to take everything from a raw context. So it will be able to pick something from a memory, and in that situation, so obviously it is going to save time, it is going to save a token, and the entire process is going to be very, very relatable and fast, right? That's the whole idea behind a memory agent. So let's try to consider, let's try to understand what is this memory agent is in a lang graph manner. By the way, how I will be able to basically create those memories, and then how conversation is going to happen at the end of the day. That's something that we have to understand. Let me change my Langsmith tracing name. So another agent. Today's date is 22nd, right? 22nd. So let me name it in this manner. Okay. So memory agent. So fine, let's try to understand how it is going to basically help me out in terms of creating a memory agent and what and all different kind of things I will be able to create. It is going to be very amazing demonstration, by the way, guys, which I'm going to give you. So first of all, let's try to do some sort of a import. So from 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 lang graph. So lang graph dot checkpoint dot memory. So there is a package which is already available, and from here, so you can try to import basically in memory saver basically. So this is something that you can try to basically import. Now this is going to help me out in terms of basically persisting a memory and in terms of dealing with the memory. So let me ping you this piece of the code. Yeah, so it's there inside your chat. Now here, so what we can do, so we can try to create a node, because we are talking about lang graph and we have seen that whatsoever things we do, for that we try to create a node basically, right? So and we try to set a nature of that particular node, and then it is going to behave in that particular manner. So here, node wise, let's create a function. So def and then memory memory underscore, let's say chatbot. Yeah. So this is basically a node I'm trying to create, and state is going to be state is going to be basically message state. We can try to set message state, the import that we have done. And now what we can do, so llm dot invoke invoke llm dot invoke, so it is going to call my GPT model, by the way. And then here, so we are going to call a state, and then inside that basically a messages, fine. So here we are going to pass a message. So whatsoever message that I'm going to receive, so I'll doing a chat basically, and then it is going to give me a response, and I'll be returning something. So return return what? So return basically messages, and then just try to return this particular response. Now, a very simple plain function I have created, which is going to take a message from the user. So let's say you are saying, hi, how are you, or something like that. It is going to take that, and then it is trying to call my LM. Simple a GPT, it is going to pass those messages, and then GPT is going to give you like a response. I'm doing good, I'm great, something like that. And then I'm trying to give it as a return. Okay, this is a simple node, a simple function which I have created. I will be using that as a node. Now, I haven't attached any kind of a memory inside this one, right, everyone? Yeah, it's a plain call, right? Yes. Can I say I haven't attached any kind of a memory, although name of this node is a memory chatbot, but I haven't attached anything so far. So it's a very plain, simple call that I'm trying to do it. Simple like a GPT call. I'm trying to do it now here. So what we can do, we can try to create one variable called as memory, and then this variable is going to be the instance of in memory saver, the import that we have done. Now here we will start our work with respect to the memory. So I will be using this particular library. So here I have created basically a simple variable memory, and then here, so a state graph, and then message state, and here, so let's try to create a builder the way we were doing it even in the previous classes. So where we have started creating a lang graph, and then we have started adding a nodes on top of that one. So fine, we have started that. So here builder and message state. So now this is basically an object which is going to help me out in terms of creating a node and binding a node and the edge. Fine. So builder dot add node, let's say add a node, and node wise what we are going to do, so we are going to basically say that this is basically a chatbot, and node wise I'm going to add a node that we have created over here. Okay. So this is basically a node. So it is going to basically create this particular as a node, a circle you can say. Now we can try to create an edge. So builder dot add and then edge, right? So edge is going to be what? So edge is going to be a start, and then from a start it should go to a chatbot, the previous one that we have created. So it is going to basically connect. Yeah, it is going to basically connect. And then we can try to basically add builder dot add edge over here, and then chatbot, and let's bring it to end. A very simple one, right? A very simple one. And then we can call a builder dot compile, and here, so checkpoint is equals to memory. Now here we are trying to add a memory, guys. This is what it is going to, and this is how we are trying to attach a memory to this one. MEMO, let me name it as a memory agent. Now AGENT, let's say. Yeah. So this is basically my memory agent, by the way. So let me show you how graph looks like. So my graph looks like this one. I'm trying to start. There is a chatbot, and then there is an end. And what I have done, so I have executed, or I'm just trying to attach a checkpoint, and checkpoint wise. So in memory saver, this is something which I have implemented over here. So now here, if you will look into this definition of this one, so as a in-memory checkpoint saver, this checkpoint saver stores checkpoint in memory using a default dictionary. So basically it is going to store, or it is going to hold some sort of a memory for you, and then eventually it will be able to use this particular memory in a next conversation basically. So here, what we can do, so if we have to use this particular memory, use the memory, or maybe test this particular memory, what we can do, we can try to create a flow basically. So flow wise, so we can try to basically create a multiple flows, and then we can try to check whether this is going to hold a memory or not at any point of a time. So to do that, let's say I'm going to create a multiple conversation kind of a situation. So config config wise, this is just a variable config, and then here, so we can try to create configurable, and then inside that configurable, and here thread ID, and the thread ID is basically, let's say I'm trying to say This is a student 001 conversation. So I'm just trying to create one conversation, one configuration for my conversation. So where I'm saying that the thread ID, so that I will be able to track. At the end of the day, I'm looking for a tracking. I will be able to track, and yeah. So basically, I will be able to track it with respect to a student ID, a particular student ID. I'm going to attach. Okay, so this is a configuration that I have created, and then I can create a student ID 2, 3, 4, 5, 6, 7, and so on. Now here, so if I have to use my memory agent that I have created, so memory, just call it memory agent dot invoke invoke, and then here, so while invoking this particular memory agent, so obviously I have to pass a human message, right? As per this agent, I have to pass a human message in a very first place. So fine, let's try to pass a human message over here. So messages is equals to, I can say, uh, human message basically, and this human message, let's say, is I'm saying my name is Sudhanshu. Fine. So this is a human message that I'm trying to pass basically to this one. And then, so message invoke is fine. There is a curly braces which will come inside this one. Yeah. And here, so configuration wise, what we can do, so config is equals to the configuration that we have created over here, so that I will be able to track it. So configuration is equals to configuration. Okay, fine. Now it is going to give you some sort of a result. So let's try to hold it inside a variable called as result, and then I can try to maybe print this particular result. So here, see, I'm just trying to give a call to it, guys, and I'm just trying to attach a configuration so that this conversation has been done by student number one. So this is how I'm just trying to attach it. I'm just trying to hit my agent, memory agent dot invoke, the agent that I have created above. Okay, now let's do one thing. Let's go here and let's try to trace it. So another agent 22nd, fine. So here my name is Dhanshu. So here output, hello Dhanshu, how I can assist you. So this is output it is trying to give. So human is saying that my name is Dhanshu, and then it is trying to basically assist you with this one. There is something wrong. So fine, looks fine to me, but I'm looking for some configurational changes or a part here. Okay, so hello Dhanshu, how I can assist you? That's cool. Now I can try to print it even over here. So from this result, basically I can try to extract this information. So messages. Okay, so from this message I can try to extract basically the last content. Hello Dansu, how I can assist you? Out of that I can try to extract basically a content. NT content. Hmm. So this is basically a response that this particular system has given to me. Now let's do one thing. So let's try to do another conversation with the same agent, and let's try to understand whether it is able to remember something in a memory or not. Now here, so my name is Tanshu. I'm not going to ask the same question. I'm going to ask that what is my name, and if it is able to give me a response, right? What is my name? It simply means that yes, it is able to store something inside a memory. Means it is able to remember basically who I am, by the way. So let's see. What is my name? So if I'll go and if I'll try to trace it, yeah. So, what is my name is the question. Your name is Dhanshu. How I can help you further? So, can I say that, guys, we are able to successfully do the implementation? Yes. Yeah. So it is able to remember. So it's very simple. I have not done much, by the way. If you will look at this one closely. So I have technically, just called this memory, and while creating an agent, so I have just attached it as a checkpointing. That's it for now. And then, with respect to one student ID, so I'm just trying to trace it. I'm just trying to basically, call it, and yeah, it is able to remember. Now this is one conversation thread basically, and this conversation thread is with respect to student number one. For example, Raj is trying to do this conversation, so this conversation is with respect to Raj. Now Saurabh will come into picture, and even he will be doing a conversation. So obviously, Raj and Saurabh's conversation must be separate, right? So basically, like, agent should remember Raj conversation as a Raj conversation and Saurabh's conversation as a Saurabh's conversation technically. So this is what I'm trying to do, a segregation. So let's do one thing. I can try to create another configuration over here. So I will try to name it as a configuration number, let's say like one. Yeah. And here, so maybe I can try to give another thread, student two, or maybe let me like give a name it as a Saurabh. Yeah. Fine. So now here, if I have created this one, and now let me try to call the same agent, right? Same agent over here. This time configuration is equals to configuration one. And here, so if I'm going to ask, what is my name? So is it going to give me my name, Tanshu? Is it supposed to give me a name? My name is Tanshu? Yes or no? So Akash saying no, everyone is saying no. Yes, I believe it should not give me because I have changed the conversation. So that thread was different. That thread was basically with respect to a student number one. And here, so I have just like, changed the thread basically. This is where this threading concept comes into picture. So for example, you are using ChatGPT, I'm using ChatGPT, everyone is using ChatGPT. Everyone's ChatGPT should remember their memory, right? Not everyone's memory, by the way. So yes, this is what technically it should, and ideally it should like remember. So fine, let's try to call it. And what is my name? Let's go and check what is a name that it is trying to give me. So here, what is my name? That was my question. I don't have an access of a personal information about a user unless you shared it with me during our conversation. So I don't know your name. If you would like to tell me your name, feel free. So can I say that it is working? So it is work with respect to one thread. Yes, it is able to give me an answer when I have changed the thread. So technically, what I'm trying to show you is that you are trying to create a platform. You are trying to create a system, and obviously by default you are going to set a nature of that system. I mean, like, it should not combine everyone's memory, right? Everyone's memory is supposed to be different. Not an issue at all. Just change the configuration. Inside a configuration, I'm changing what? I'm just changing a tag, thread ID. It is as simple as you can see. Very simple, right? Change a tag. So likewise, you can handle like 1,000 users, 10,000 users, or millions of users, and everyone will be having their own memory. As simple as that. Fine, guys. Any question? Yes. So simple, create a thread ID. With the help of thread ID, you are able to manage it. So likewise, you can try to create hundred thousands. It doesn't matter. It will be able to manage and maintain. Okay. Fine. So this is one of the agent that we are able to create, and now we are able to see that how we can try to deal with the memory. Now let's try to understand another agent, a next agent. So next agent is going to be human in the loop. Viresh is asking me question how the threads are created in real time. Simple. So basically, you are going to pass a login ID. So every user that you are going to handle, so they will be having their own ID, right? In your databases, you are going to maintain or manage with respect to a ID. Maybe their ID can be a ID that you are going to create in a unique manner or maybe while combining their email ID, phone number, or something. I have given name. You will just try to pass their user ID. That's it from your DB. This is how happens in a real time. Can we also configure a big memory size for a large conversation so that we can efficiently answer without forgetting the context of it? Yes, we can. basically do it, and we'll be doing it. But yeah, so in a later stage, obviously, we'll try to talk about long-term memory, short-term memory, each and everything. We'll try to combine it. Yeah, but yes, this is the base principle. This is the base philosophy of a memory. Now let's try to understand a human in the loop, HITL. So human in the loop. A human in the loop simply means that agent will try to do some sort of a task, and whenever required, so it is going to ask a human. That's a simple definition of a human in the loop. Very very simple. So here, what we can do, so we can try to maybe build a agent, so which is going to ask for a human approval if we are going to set that up in that particular manner. So let's go ahead. Let's try to build this one, human in the loop agent, right? So it will be agentic, but yes, it is going to consider human as well. Depends upon my entire flow, or maybe some sort of a sensitive information. If it will try to extract, so obviously it is going to take approval from a human. So let's try to create one tool over here. So send email, let's say demo. This is a tool which we are going to basically create. What it does, so it is going to take email as a string, and then it is going to take message as a string. Fine. It is going to take these two, and then it is going to, let's say, return a string str. So this is a simple normal function I'm going to create, and then let me write a doc string for this one. So this function is a dummy function which is going to demonstrate of sending an email to a particular user. So fine, doc string I have written in this particular place. Now a return. So return wise, what it is going to return? So return wise, it is going to return maybe a formatted string. I can try to put demo email sent to, and then email, and whatever messages that you are going to send, message. Fine. So I'm just trying to return this one. Now, if I have to convert this function into a tools, what I'm supposed to do, guys? If I have to convert this function to a tool, quick. Decoration, I think we all know. We all have done that so many times last day. Yeah. So fine, this function will get converted into a tool. So I have just decorated with the tool, the import that we have done from a lang chain. Okay. Now here, so what we can do, so let's go ahead and let's try to create a node. But before that, let me bind this tool with the LLMs. So here HITL underscore TOOL, HITL underscore TOOL tool, this variable, and then inside a list, I'm going to keep this tool. So I can have one tool, I can have 1,000 tools, depends, right? Last time we were having like a multiple tools as well in the previous class. LLM dot bind, and bind what? So bind this particular tool. So we will be using this LLM instances. So this brain will be having this particular tool access. So HITL underscore MODL model. Fine. So now this LLM will be having this one if I'm going to call HITL model. Fine. So tool is done. This one is done. Now we have to create a agent. To create an agent, obviously I need a node, right? I need a node. So here def and then HITL underscore agent underscore node. Let's say I'm going to create a function for that, right? This function is going to help me out to do this one. So message state is equals to message state, and then HITL model dot invoke. So it is going to invoke my LLM, and then it is going to basically pass this state message. Messages. It is going to basically pass. Now it is going to give me response. Now whatsoever response it is going to give it to me, I'll just do a return of it. So here messages is nothing but a response coming from here. Okay, so this is a node that I have created, guys. Now this node is not doing anything fancy, by the way. So this is just trying to call a LLM. So LLM dot invoke, the way it was calling in everywhere. The only thing is that I have attached a tool to it. This tool is basically dummy, by the way. I mean, I'm just trying to like demonstrate a email and message send in a real time. So obviously, I'm going to call the email, which also I'm going to show you. Don't worry. So I'm going to show you a lot of integration, WhatsApp integration, Gmail integration, basically Telegram integration. All those integrations can be done, and I'm going to show you with a real time. As of now, just try to understand this part. Okay, so here what we can do, so we can try to import couple of libraries. So from lang graph dot types import. So import what? So basically import interrupt and then import command. Okay, so this is the import that we have to do from a lang graph, and then what we can try to do. So we can try to basically create a node which will be looking for an approval. Basically, we can try to create a function, or we can try to create basically a node which will be looking for the approval. So basically, a approval function we have to write, and all of those logic basically will go into that particular approval function. So whenever approval is required, I'm just going to attach that particular approval node in between while creating the agent. So let me show you the approval function. So how this is going to actually work, little bit bigger. So approval node I have created, it is taking a message, right? It is taking a message. So the previous node, right? Previous node was like a human in the loop agent node, and which was just trying to call my LLMs, and then it was trying to give you the response. So let's say if I'm sending a question saying that you have to send a mail to a user. So obviously, if I have to send a mail to the user, it will come to this one, and then it will feel like that I have to take a human approval. So it's not like I should send a response directly. So let's imagine this kind of a situation. So in that situation, so it is going to call the approval node. So it is going to pass its own message, whatever AI message system is going to decide, right? That okay, fine, so I would like to access your function, I would like to access your tool, but are you giving me the approval, right? Are you giving me the approval? So here from a tool we are trying to extract a message, whatever sorry, from AI we are trying to extract the message. So whatsoever AI is going to understand, basically my LLM will be able to understand that okay, in this situation I need that one. So this is what we are trying to do. So from the state message -1, the last one we are trying to extract, so that is going to be the like a last message. And then this AI message dot tool calling I'm trying to do. So it will try to call my tool. Now decision we have to take, right? So whether it's a approved decision or whether it's a disapproved decision. So this is where this import is coming into picture, interrupt. So here we'll try to take a decision, and where this interrupt is going to help me out. So message is equal to human approval required, right? Now tool call name argument for that particular tool calling. So here it is going to make a decision. It is going to build a decision. Now if this one is going to return, right? If this interrupt is going to return approve. So in that case, do one thing. So send email demo dot invoke. So in that situation, just try to call it. Just try to basically call it, and then like send a email, and then do a tool calling. Uh, and then it is going to like show you the tool result, and it is going to basically show you the tool ID. Now so this is what it is going to do. If it is going to be rejected, so in that case it will come to this return, and it will say that human have rejected this particular actions. As simple as that. So this is how, guys, we are trying to make a decision. This interrupt is helping me out to interrupt a process, agentic process in between, and ask for the approval at the end of the day. Simple. So fine, this is one of the node that we have created. Now once we have created this particular node, so obviously we have to do a routing in between basically approval and not approval, because in every cases obviously it should not go and execute this one. So let's say if I'm saying just hi, how are you, it doesn't require any kind of approval, right? So I have to basically create that particular approval node in between. So let's go ahead and let's try to create one node. So need approval node, which is going to take the current state. It will try to extract the message, last message, right? And then if get attribute of the last message, tool call none, return approval, otherwise return end. Fine. So this is one that we have created. Now, once everything is done, let's do one thing. So let's try to start creating the graph, or let's start creating the agent over here. So here, what we are going to do, so not this one. So first of all, we are trying to call a memory. So we are trying to involve memory as well, the memory that we have discussed just now. And then this is going to create my object of a graph, and then object dot add node. So I'm trying to add my agent, HITL agent node, the small one that we have created. So there will be HITL node. And then after this HITL node, so again, I'm trying to create another node, approval node. So two node I have created, agent and this one, and then edge. So start and go to the agent that we have created. Now, so here we are trying to add a conditional edge. Even last time we have used a conditional edge, right? So agent, and if it is telling you that need approval, then obviously you have to need a approval, and if you are able to get the approval, then after that end it means call the agent and then complete the task. So here builder add agent approval agent, and here we are trying to basically add the memory also. So now if I'll show you how this graph looks like. So simple start, come to the agent, right? If approval required, go to the approval one and then get back with the approval. If not required, then in that case, come to the end. So this is a simple thing that we have created, and there are two nodes to it. One is a agent node and one is a approval node that we have already attached. Fine. Now if we have to execute this one, so we are trying to use a memory. So if we are trying to use a memory, so obviously I have to create a thread as well. Yeah, thread as well. So let's go ahead and let's try to create the configuration. So same configuration, let's say this is my thread one, for which I will be able to track the memory. And then let me invoke my agent finally. So let me invoke my HITL agent by the way. So here HITL agent, let me invoke it. So here message is human is trying to message that send an email to demo@example.com saying welcome to a agentic AI. So I'm trying to send basically a mail, right? I'm trying to send basically a mail. Okay, fine. And I'm just trying to attach a memory as well. So execute. Okay. So it is able to execute this one. And here, so if I'm going to print basically a result, if I'm going to print a result, so you will be able to see that it has called the interrupt. If it has called the interrupt, it simply means that, and it is telling you that human approval required, tool send image argument this. It simply means that yes, it is working fine for me, and it has actually waited for a human approval. So it is not trying to execute all of these things automatically. Even here inside a trace, I will be able to see. So send an email to this one and send an email demo. Call this basically like a thread ID or agent ID. It is trying to call, and then email is this one. Welcome to the agentic AI. So yes, it is trying to basically here it is trying to call the interrupt, and it will not be able to send it unless and until we are not going to approve it at any point of a time. So this is how we can try to attach interrupt, guys. And with the help of interrupt, so I will be able to either approve or I will be able to either disapprove, basically. So this is how we can try to create human in the loop, and then if I'm going to approve, so it will basically ask, and how it is going to ask, so that we can try to configure it inside our console, and we can just say approve, so it will go and do it. If we are saying disapprove, so in that case, it is not going to do it. Make sense, everyone? Yes. So now let's say we are trying to invoke this one. Here we are trying to basically invoke this one. So HITL human in the loop dot invoke, and we have sent this particular message, a human message with this one. Now here, so it has interrupted. It has interrupted, and technically it is waiting for the approval. So what we can do, so maybe we can try to give a command. We can try to pass a command, and this is where we have basically done an import of this command. So we have done an import of this command, which we have not used it. So what we can do, we can try to pass a command. How we'll be able to pass a command to this one? So it's again very, very simple. So we can simply try to say that okay, so agent dot invoke and command resume. with the approve, because it has interrupted, right? It has interrupted and it is telling me that, it is waiting for basically, like, approval. So it is waiting. So what I will do, I'll just try to send a command approve. Now let's see what happens. Assert response could not resolve a response should happen bad request. During a task with the name agent, and ID of this agent is this one. Invalid request error. This one. Okay, let me. This has failed. Bad request. Resume. No, it should actually like work. Let me pass this command with a message. Even with message, it is giving me an issue. Demo, let me change a thread. And then approve. Let me check what is the issue. Configuration 3. So basically, it should take my command, guys, for approve, because last time it is giving me interrupt, which by default it is trying to call, which is a good call. But it is not able to take my command. There is a issue it is showing. User request this and this one, fine. Still failing. Config demo 5. So till interrupt, it is working, but when I'm trying to resume it, so interrupt is not giving me any issues. It is working, but when I'm trying to resume it, it's giving me an issue. So fine, guys, we'll check. We'll try to, because it should actually work. If interrupt is working, so after that, it's just a command, and I just have to give approve for a particular configuration. Configuration is also correct. Basically, I'm trying to maintain just a particular thread with respect to a configuration. Pin your code. We can also try from our end, sir. Okay, let me ping you. It's a small one. It should ideally work. I mean, this should take my command, which it is not taking. Fine, we'll fix it. So fine, everyone. I'm pinging you the code. This one for tool creation. This one for an object of your tool. This is for a simple agent, and then this is for a approval, and then fork we are trying to create, and then the agent, and then the call. And this is the piece where we are getting issue. Okay, fine. So maybe you can try to debug. Even I'll do it. Yeah. Fine. So this is how basically, I can try to create a human in the loop, and then I can try to basically approve or resume. So with the help of interrupt and with the help of basically command. So command means giving a command, approve, disapprove, or whatsoever command that you are going to create. And interrupt simply means that I'm trying to interrupt based on certain conditions. Now, so the next agent that we have to create is a multi-agent supervisor. So there will be a multiple agent, right? For example, I'm trying to create a coding agent. I'm trying to create basically a writer agent. I'm trying to create basically a research agent, and then it must be able to, supervise all of these agents. So technically, it should maintain and manage that. Okay, fine. Who is going to do what kind of a task, basically, and then coordinate in between the agents. Yeah, Rishabh is saying worked for me. Yeah, I mean, code wise it's fine. Maybe I'll restart my VS Code, it will work. So code wise there is no issue. It's a very simple code. But yeah, I don't know why it is giving me an issue. I am not able to see the issue because I mean the trace that it is giving me, right? Everything looks fine for me. So maybe I just have to restart the kernel because of the thread ID, right? It is getting confused. That could be the only issue which I can see. So maybe I'll restart and then it is going to work. Restart my kernel because yeah, its behavior is going to change based on the thread ID in which I'm trying to maintain. If there is a bad message which has been already logged or checkpointed, so in that case, it might give me an issue. As per this one, invalid type for message to content. This is what the error says. Okay, fine. Let's go ahead. It will work. Same thing will work. So now let's try to call or let's try to understand the supervisor agent. So what this, yeah, worked. It will work for everyone except me. I just have to restart my kernel. So just check my this error message as per that. Just restart the kernel and then it will work. Now here, so what we are supposed to do, guys? So we are basically going to create a supervisor, and supervisor is going to supervise one or the multiple agent. That's what it means, by the way. So maybe we can try to create a research agent, we can try to create a coding agent, we can try to basically create a writer agent, and automatically it is going to decide that okay, fine. So which one is supposed to do what in what kind of a situation. So now let's go ahead and let's try to do it. So here I can call from LangChain, LangChain, LangChain dot agents import create agent. It should work, I believe. No model. LangChain is not available. Wow. Last time we have installed it. LANG. Yeah, we have already installed this LangChain. LangChain is not available. That's weird. So pip install updated one LangChain. Requirement already satisfied. Restart my kernel. No module called as. Yeah, still I'm getting this issue even after restart. LangChain is already available. We have already done the installation in the same environment. And even here it is telling me that requirement already satisfied. But when I'm trying to call it, it is telling me that LangChain is not available. I don't know what is going on with my system. It's a system issue, guys, not a like code issue or syntax issue. It's just specific to my system. Even here, it is not able to. LangChain core, it is able to find out. LangChain OpenAI, it is able to find out. Protocol, it is able to find out. But vanilla LangChain, it is not able to find out. No, in this environment itself, like we have done those installation. It seems, yeah. Last time we have done that, right? So environment was same. See, LangChain done already. Even it is showing me that requirement already satisfied. It simply means that it is available. It is not able to call it here. You had installed in a base environment. LangChain core requirement already satisfied. Lang CHAIN chain. Now it's fine. It'll work. Yeah, it'll work. So fix that issue. So here, what we have to do, so we have to basically, call this LangChain agent, create agent. Now, after doing that, so we can try to use this function, create agent function to create a agent. So far we have been doing a lang graph, so where we were creating a node and then we were creating a edge and we were trying to connect node and edges, right? And this is how we were trying to create the agents inside a lang chain. So I mean, like, it's not a graph, right? So we can just try to call a create agent and then we can define everything, and I will be able to create an agent, which is very, very simple. So simple, just try to call a create agent function, and inside that, obviously, agent requires a brain for which LLM is required. So model is equal to LLM, the LLM that we have done as an import. If you are going to give a tool to it, so you can try to use a tools and the bracket. You can try to give a tool to it. System prompt, if you would like to set, so you can try to set a system prompt as well, that you are basically a research specialist and give a concise explanation and do a proper research before responding back to the user's message. So fine, this is a system prompt that we have set. Technically, this is what happens with respect to an agent. So agent requires a brain, agent requires a tool, and agent require a system configuration. So here, let's say with the help of this, I'm trying to create one agent and I'm going to name this agent as a research agent. Research agent. Fine. So this is one agent I have created. Let me ping you this piece of the code so that you guys can execute it. All of you. Yeah. So in a graph, so obviously we try to create a node first, then we try to create an edge, and we try to connect it. We can try to create a fork as well in between. In case of a lang chain, simple, call a create agent function, pass a brain, pass a tool, pass a system prompt. So one agent is created. Okay, fine. LLM is not defined. Oh, I have restarted my kernel, right? So I have to re-execute this one. Fine. Okay. So here I'm trying to create the research agent. Now let's try to create another agent. So to create another agent, create underscore agent function, create underscore agent function. Same thing I'll do. I'll just repeat the same thing. Model wise. So LLM, it is going to take tools wise. So it is going to, like, I'm just going to keep it blank for now. I'm not providing any kind of a tool. System prompt wise. Sorry, system prompt wise. So I'm going to say that you are basically a coding specialist. So whenever user is going to ask any kind of a coding related question, so try to investigate properly and then try to give a response, and yeah, in a programming language that user have asked for. Otherwise, use Python. Okay. So system prompt I have given, and then here I'm trying to create a coding underscore worker. So fine, another agent has been created. So two agent I have created. Now let's try to create a third agent basically. So here, create agent, and then inside that, same thing I'm going to repeat. So model is equals to LLM, tools is blank, and then system prompt. So I'm going to say that you are basically a writer agent. So whenever someone is going to ask you to write something, or proper like an investigation is required, and then only you should write, and always try to be a creative with a IQ level 200. Okay. So here I'm trying to create one agent, writer agent. Fine. So three agent I have created with the help of LangChain library. And again, it's not very difficult. So in my last class, I think some of you have even asked me that are we going to create an agent with the help of LangChain? So yes, we are doing it. And as you can see, it's very simple, right? It's very simple. So in case of a Lang graph, it always follows the philosophy of node and edges, and then connect each and everything and create an agent. Now here, so in case of a LangChain, it's a create agent function. And with the help of that, you will be able to create it, right? You will be able to create it. So three agent creation is done. Now what I'm going to do is that after this one, so maybe I can try to basically create a tool over here, a tool which is going to select one or the other agent at any point of a time, right? One or the other agent it is going to basically execute. So when people are going to ask a coding related things, it is going to decide and it is going to basically invoke coding agent. If someone is going to ask for a creative writing, so in that case it should invoke a writer agent and then a research agent, because I'm trying to create what I'm trying to basically work on multi-agent supervisor. So there should be a supervisor which must be able to do all of these things. So fine, let's go ahead and let's try to create that tool. Yeah. Yes, I'll come to that point because I know like Saurabh has asked me one question. So is it not similar to a router agent then? I'll come to that point because just by looking into the supervisor agent, obviously you are going to ask me a question that, we have already created a router agent, which was again trying to route to one or the other. So how this one is going to be different? So I'll come to that point. I know this is a question which is like going to come for sure. So obviously we have to understand a difference between basically a router agent and we have to uh, understand a difference between a multi-agent supervisor. Fine. So here, first of all, let's go and let's try to create what? So let's try to create a tool. So which is going to decide that which agent will be selected. So def tool creation wise, ask underscore researcher, and here, so let's say task someone is going to give in a str format. It is also going to give you a response in a str format, and then here I'm going to say ask the researcher agent, and here researcher agent dot invoke, and then we are going to pass basically a messages. So messages is going to be role, user, and then content wise means message wise it will come from the variable task. Okay, so it will be coming from there. Okay. There is a issue. So this one is closed. This one is closed. Message, and inside this message, I should put one more curly braces. It seems. Yeah, that's fine. So this is basically a researcher agent, and then I will be like returning something out of it. Return. So return what? So let's say I'm going to hold this entire information in a result, and then here result of messages of last one of content. Yeah. So this is going to basically return. If I have to convert that into a tool, so I'll just try to convert that into a tool by doing a decoration. So now this will become one of the tool. Okay. So one tool is created. Let me ping you that. Yeah. Now, so similarly, so we can try to create a tool for a coder. So I'll copy it and then ask coder. And here coding agent I'm going to call dot invoke user task. Everything is going to be same. So there won't be any kind of a differences at all. So fine, I'm going to change this doc string. So you are basically going to invoke a coding agent. Fine. Now similarly, so I can try to create a writer agent. So ask writer, So you are basically a writer agent. And here, writer agent dot invoke, rest of the things are going to be same. Yeah. So three tools we have created over here, and three agent we have already created over here. So now, how I'm going to create a supervisor, basically, or uh, now how I will be able to create a supervisor, how I will be able to invoke a supervisor. Now, to create a supervisor, even a supervisor, you are going to use the same philosophy, because supervisor is also an agent. So all three agent I have created. Supervisor is also an agent. So if I have to create a supervisor agent, I will be using the same function called as create agent. And whatsoever I have done so far, so I will be doing the same. So model is equals to LLM. Now tool wise, TOOLS, tools wise, what we can do, so we can try to give an access of all these three tools that we have created. So basically we have created a ask coder, ask researcher, and then we have basically ask writer writer. So here tool wise, I have given all three tool access to this particular one. Now, so researcher agent or writer agent or coder agent, they don't have any kind of a tool access. Basically, I'm giving this to this particular agent so that it can go and it can try to search, and it will be able to execute the respective one. So tools are technically calling the agent. Yeah, tools are technically calling. So if this tool will be called, and tool will be decided by whom? So tool will be decided by basically this particular supervisor. Now let me set a system prompt from this one for supervisor. So here system prompt wise, I can say that you are basically a supervisor, and your job is to find out a respective agent who can do a particular task at any point of a time. So who, if researcher agent has been called, then you have to call basically a researcher agent. If writing work has been given to you, so you should call a writer agent. And if coding work is given to you, so obviously you should call always a coding agent. So always try to select your tools carefully. You can also call a multiple worker if you want. I don't have any kind of a issue, but yes, it should always be called after a correct evaluation of the input. So fine, this is basically a system prompt which I have given to my supervisor agent, right? And technically, this is having a tool access, and tool is technically accessing all the other three agents. So if I have to represent this one, so I'm just trying to uh, do something like this. There will be user, right? User is going to send the message. Whenever user is going to send the message, it will go to supervisor. Now supervisor is having basically a tool layer, right? So here we have a tool layer, and this tool is calling either a writer or a coder or a researcher, right? So this is basically a setup that we are trying to do it as simple as that in this particular situation. So fine, guys, let's go ahead and let's try to do it. So here, if I have to invoke someone, so I can try to invoke basically a supervisor one. So here supervisor dot invoke invoke. So I'm just trying to call, and obviously when I'm trying to invoke it, I will pass a message over here. So let's pass a message over here in that case. So here messages, right? Okay. So here I'm going to define a role. So role is supposed to be, let's say, user, and then I'm going to pass content. Yeah, I'm going to pass a content over here. So fine, content wise, what we can do. So let me pass, explain me the vector database, and even try to show me some Python examples with respect to our vector databases, and uh, create or give me a beginner friendly explanation about a vector database and a Python code that you are going to produce. So I'm looking for a correct explanation for the same. Okay. So this is basically a message, guys, the content which I'm trying to send. And then this is basically a coding related task. As you can see, this is basically a coding related task. So ideally, I'm assuming that it should call my coding agent, right? Will verify. This is a coding related task. So it is going to give you result, right? It is going to give you result. So let's execute it. So my agent is getting executed. Okay, fine. So now here result of result of messages, right? So result, if I'm going to show you, so it will look like this one. It's won't be relatable. So let me, like, extract the relevant information. Messages of -1. So fine, and then dot con content. Okay. So we did a type of the database designed to store search data interpretation, this, and then it is trying to give me some sort of coding explanation as well. I just have to do a formatting. I'll go to my Langsmith, and here, so you will be able to see a beautiful output, right? So what I said, explain me this was my input prompt. So output wise, what has happened? So output wise, it is trying to give me like this explanation, and then basically AI wise internally, what it has done, so it has called two agents, by the way. So it has called a researcher agent which can do a research on a particular topic, and then it has called a coder agent as well. Yeah. And yeah, so these are the response. So tool calling wise, as you can see, it is calling two tools simultaneously. So technically my supervisor is trying to uh, supervise, and supervisor is trying to use 2 3 10 whatsoever is required. Now can anyone tell me, just by looking at this example, right? So basically Saurav has asked me a question that how it is different from a router. Look at the answer and look at the tool calling. Can anyone tell me what is the difference between router and supervisor? Do you still think both are same? Yes, or are you able to like understand the difference between supervisor and a router agent? Because router agent we have already created. Now we are creating a supervisor agent. So router will go only to one agent. Here we are able to decide and go exactly. See, so basically here, if you will observe, right? Basically here you will, and this is what I have configured in my system prompt. If you have seen my system prompt, so what I said that yeah, you can feel free to use a multiple agents also. So here in terms of supervisor, for example, you are supervising some of the task, right? Let's say someone has given you to build one digital product. So you need a designer, you need maybe a coder, you maybe need a like architect, you need maybe a tester, you need a lot of people, right, to build that or to produce a final output. So as a supervisor, what you will do, so whenever you need basically a designer, you will just call designer from your team. Whenever you need this, that, so you will be calling that from your team. And then with the help of those so under your supervision, so you are controlling technically, right? You are controlling, you are supervising, and you are coordinating with each and every one. And eventually you will be able to produce the final output. This is what a supervisor does. Even in real life, this is what happens, right? Routing simply means that okay, fine. So I'll send to one route and then end. That's it. There won't be any kind of a back and forth communication. So can I say that yes, we are able to do this one and we are able to get a beautiful result, as you can see, right? A vector database is a type of database designed to store search data representation. Beautifully, it has given you this text, guys. See, yeah, and even example wise. So it has given me like a FASI, basically FIASS, right? And its example in a beautiful manner. Fine, and then you must be able to like see the trace of everything. So when what is been basically called, so when model has been called, basically when my like a tools is been called, everything you are able to observe. So makes sense, guys? A supervisor agent. Yes. So one more question: who is a orchestrator? See, orchestrator simply means that someone who is trying to coordinate. So on a framework level, if you are going to ask me, it's a lang chain that we are trying to use. On a code level, it's a supervisor. I mean, like you can say orchestrator as well. I mean, like or supervisor is technically trying to orchestrate each and everything. So we have created a supervisor agent here, right? See this one, this. So this basically agent is trying to orchestrate all three of your agent, all the above one. Yeah, simple. So this is how supervisor is working. Beautifully, we are able to see the result. Yeah, the way we were like looking for. So likewise, you can try to create any kind of a n number of hundreds number of a specialized agent, and then put it inside a supervisor. Supervisor will decide what to do and what not to do. So last since last couple of days, personally, I am working on one of the agent. I would like to show you. So basically, we have a Euron system, right? So now what we have done, so we have brought down the entire things. I mean, like entire demo integration, each and everything to a 30 seconds. So anyone, let me uh, contact at the rate Euron. So this is a very big and massive project that we are trying to spin. And it is giving a lot of challenges, by the way. So personally, I'm involved into this one. I'm fixing a lot of bug since last like 3 4 nights. I think by next week we are going to release it. Yeah. So what happens? So we have so many products over here. So technically anyone can come, or you can go and check some of our clients as well. So you will be able to see here. So basically we have like a lot of things over here. We have a lot of templates over here. Basically, template wise. So we have, yeah. So we have 50, 60 like templates over here. So anyone can come and anyone can launch their website, and just they can select their own template. They don't have to do anything. And even course creation wise, course wise, live course they can try to create, hybrid course they can try to create, shorts course they can try to shorts based courses, book based courses, roadmap based courses, blog, webinar, bytes, bundle, everything means whatsoever you can think about in a digital system, so a digital product. So you will be able to create it. Even test series, basically, for IIT, for UPSC, for CAT, JAT, MAT, anything for SAT, you will be able to create it, and everything is technically AI driven. So you just have to go there, and even if you have to create a pages or website, so simple, you can go over here, and everything AI will be able to take care of. Now, what we are trying to do, if I'll show you my dev system, Euron systems, mm, dashboard. So if I show you the dev dashboard, it's in a development environment. So we have not pushed it inside the production environment. So now what we are trying to do, so we are trying to create a very big, massive layer. Yeah. So we are trying to create a very massive layer, and you can see a lot of testing is going on, right? So all of these things, all of this testing I'm trying to do from my account, and parallelly I'm trying to build it so that you don't have to even go and click, because we have a 65 plus product, right? So like too many products we have, so you don't have to go and control all of those 65 plus product. You don't have to go and even do one click. Even if like there's a AI, click it and then say it, and then it will do it. But what we, even let's suppose if I have to send a mail campaign, if I have to send a WhatsApp campaign, if I have to send basically, if I have to configure my website, if I have to change the theme of the website, if I have to launch one courses, one bundles, or maybe reels based, source based live courses, anything. If I have to add some mentors, if I have to understand the stats, if I have to basically understands about my competitors, if I have to, if I need maybe a co-founder over here, so who can, a digital co-founder, AI co-founder, so who can assist and who can help me out with respect to my business growth, by the way. So here we are trying to create, so what we are like trying to do, so we are trying to remove all the click based layer, means no one is supposed to go and even do a click. So basically, people can come over here, they can speak, they can upload the document in whatsoever format they want. They can just prompt basically, or say to the system that okay, I want to launch this course, and maybe you can give some sort of a heads up. You can give a dump of your syllabus. It will be able to create it. You can give a dump of your videos, right? It will be able to arrange all of those things, summary, this, that, everything it will be able to configure. So means now we are moving towards AI system, right? Where there is a click which is required. Obviously, you have to go and you have, and very minimalistic click even in this system. So we have made sure that as compared to any system which is available out there in this entire world, right? So people are supposed to do a minimal click and minimal work, and even one person will can behave as a, like a one who can handle operations of hundreds person, right? So operations, because all of these things comes inside the operational part for any edutech or for anyone who would like to sell their digital product, basically. So instead of hiring 100%, one. And now we are even trying to optimize that one person job so that you just speak, don't go and click, so you don't have to go through all of these tabs and get yourself familiar with. Just go over there, like say it, and then it will be like a done. So here we are creating a lot of testing is going on. I'll show you my trace as well. So here, where is my language? Yeah. So tracing wise, so yes, all of this tracing is actually coming from my uh, local and OPT. So these things are, this tracing is coming from, so lot of tracing we are, where is my trace? Yeah. Yeah, so a lot of tracing we are trying to do, a lot of things we are trying to do, a lot of experimentation. So here, almost you can say we are trying to create more than 230 plus agent we are trying to create, because that is the number of a task that we have basically, like, found out that, in general anyone can do it. So one task, one agent, then orchestrator agent on top of that, or supervisor agent, and this is how we are doing it. And yes, we are trying to use a LangChain and LangGraph itself, plus LangSmith. Language is not Python. Language is basically TypeScript, because LangGraph also supports TypeScript, JavaScript based, like, programming languages. So we are using that and we are building it. So yeah, real time example, so that you don't have to do anything. Just come, say a word, right? And everything can be done. Maybe from your mobile itself, you will be able to control everything. So multi-agent supervisor sort of a setup you have inside a Euron system, right? So exactly, yes. Yeah. So we already have an agent. So the system that you are able to see and the system that our clients are using as of now, so we have an agent. For example, if you have to create a courses, right? So you can go over here and then basically, you can give a name to it, and then here, so you will be able to see the AI part. So you have a AI, you have a global AI, you have a local AI, which will do everything for you, right? So here we are trying to do agent call, we are trying to do LLM calls, no doubt about it, and then we are trying to do a structuring of the output of the LLMs. But now we are moving 5 step ahead, so that don't have to come and touch your system. Simple. In this manner, anyone and everyone will be able to do it. So that's a system that we are building. I believe in next, like, 2 week max to max after testing, we are going to literally, like, make move these things from our development dev to prod. So personally, I'm working on this, by the way. Here, CEO agent. So I have renamed it as a co-founder agent, actually. I'm working on that as well. So that task is almost done. So the co-founder one. Yeah, this name is better than CEO. So CEO is like a vague one. So I just, like, renamed it as a co-founder. So yes, once we are going to make announcement, so maybe I'll come to class and then I'll show it to you, the working one. And not to, I don't have to come and showcase. You can also log in and you can check. Right? There's an open system that we have, right? Your own systems. So anyone can come and experience that agent part. So what I'm trying to say is that mm, we are also creating it, and we have already created, like, a lots of agent in so many places, and even in our product, so we are doing the same thing. Okay, guys, so supervisor agent, I believe we are able to understand. Where is my trace for today? This one. Hmm. Now, so any question, guys, with respect to supervisor? I think supervisor is done. Is there a need of multiple supervisor as well? Yeah, you can do that. That depends upon your architecture and complexity of the task. If things is not working in a proper manner, then see, at the end of the day, supervisor is what? I have just named it as a supervisor, right? And set the nature of it. And then I'm just doing a configuration in my own way, as per my own task. Technically, it's a create agent function that we are using. So it's an individual agent. So cluster of agent I have created, and then I have decided that okay, fine. So I will configure things in this manner. Make sense? This is what we are doing. So technically, it's philosophically, it's a single agent. Why I'm calling it supervisor? Because of my configuration. That's it. Yeah. Another agent node. In this case, it's not a node, I would say. Node is in a lang graph. Here I'm using like a lang chain. So in lang chain, there is nothing called as node. But yeah, I mean like simple, same understanding. So it's not very fancy things, and you should not think like it's very fancy and maybe what is going on. Not like that. It's very simple to understand. Okay, so now next one. Which one is the next agent, guys? Yeah, next one. What is the next one? Handoff. What is the meaning of handoff? Yeah, handoff means as a plain English meaning of handoff. So we are going to hand over after this one that okay, fine, you take care of this. So it's not my job, it's not my responsibility, kind of a thing. So that's called as handoff agent. Fine, let's go ahead and let's try to create it. Right. So here, what we can do, so we can try to basically create a identity class for a validation. So question will be string. Let's say department handoff log. It will be in list so that I can capture the log. Answer fine. So this is basically a identity class. Yeah. And then what we can try to do, so we can try to basically support state and then handoff decision wise. Two identity class I'm going to create. One is a base model is not defined. Is it? I think I have done an import. Okay, not done. Okay, so base model, fine. So there is a department and then billing, technical, and a human department. Let's say we have. Fine. Now what we are going to do, so let's try to attach this department to the LLM so that LLM will be able to understand that how many departments we have. So LLM dot, and I can try to basically with structured output. Okay. And I'm just trying to attach basically a department class. So the one that we have created, handoff underscore LLM. Okay, fine. So this is what we have done. Now here, what we can do. So let's try to create this function, general support function. What it does, so handoff LLM and then invoke. So decide which department should own this support conversation, a billing department or technical department or human department. So let's say you are trying to build a machine, you're trying to build an agent for Flipkart, Walmart, or maybe for your own business. Obviously, in your business, there will be multiple departments, there will be multiple teams. Even in our cases, for example, like Euron cases, so yeah, there are multiple departments, multiple teams, and basically some people will raise a ticket with respect to a billing. Some people will raise a ticket with respect to some bug or some issues they are facing with their IDs, or maybe with platform, or maybe with app. Some people will raise a concern with respect to, like maybe some explanation part. Maybe they have a doubt, maybe they are not able to do something. So different kind of complaint people are going to raise, and one person in a system can't solve it, right? Technically, one person in a system can't solve it. So we need a multiple team, so who can look into and who can even coordinate. So we need a coordination as well, right? So we need a kind of a supervisor who can understands overall the queries, and then it can coordinate, and then it can hand over to the particular agent. So now that particular agent owns the particular job. So this is where this things comes into picture. So for a general support, let's say I'm created the function. So if someone is going to ask a question, so obviously it is going to decide, this one is going to decide with the help of LLM that, okay, so the conversation that user have started, so it belongs to which department, a human department or billing department, or maybe a technical department, right? It is going to, and it is going to basically give you the return as per that one, and then it is going to basically log it. Simple. So this is one function that we have created now. So what we can do, so for a billing department, so for every department will be having their own function, right? Every department. So billing department, we have a billing support. So you own this conversation, and then simple return the state. So this is for a billing department. Similarly, for a tech department, so if technical question will come, they own the conversation. And then human department, so they owns their own conversation. So there are three functions I have created, right? So one is a billing, one is a tech, and one is a human, by the way. Okay, fine. Now, so we have to basically do a handoff routing as well. So handoff routing state, and then send it to the respective department for a routing. Now here we can try to build a graph. Yeah, we can try to build a graph. So one by one, let's go ahead and let's try to build a graph just the way we have built it so far. So a state graph builder object and adding a node. So one is a general node, right? What general node will do? So general node will take a decision that which one is supposed to handle it. And then I'm trying to add what? I'm trying to add a billing node, I'm trying to add a technical node, I'm trying to add a human node. So in total, four node I have added, as you can see. One is a general, then billing, then human, and then basically a technical node I have added over here. And then I'm trying to add a edge. So first of all, whenever user will start the conversation, it will come to my general node, because my general node is going to decide it should send to which one. I mean, like behaving like a router, right? So from general node, we are trying to add a condition that it could go to a billing, it could go to a technical, it could go to a human. Depends what general node is going to decide, right? So here builder, so if it is going to a billing, then end, technical, then end, human, then end. End of the story. Now, if I'll show you my graph, so this is how my graph looks like. Yeah. So it is coming here, going to the general. Now from general, it can go to anyone, and then it will come to a end, right? It will come to a proper end that, okay, so we are able to hand over and we are able to do each and everything. Now, if we have to invoke this one, right? If we have to invoke this one, so let's say, so we are calling it like a handoff agent dot invoke. Question wise, I was charged twice for my subscription this month. So now let's see the result, how result will look like. So here we can come, and then we can try to check over here. So I was charged twice for my subscription. So the answer is basically, I'm sorry for inconvenience. Please provide your account details so that we can review and invoke. And who is our department? So department is basically billing. So here, when it will come to the general node, it is deciding that, which department it should go to, and then it is calling a route, handoff route, because now I know the department should be billing, so it will hand off, and it is going to hand over to the billing department, and then billing department is trying to use its like memory, basically like whatsoever you have configured inside the billing department, and it will try to do a job. Make sense, guys? Yes. So now again, you can ask me a question. What is the difference between handoff agent and a routing agent? So how this handoff agent and routing agent is different? Any idea? Anyone? Yes. Handoff waits for the output after handoff. Okay. Is kind of a sequential wait for the output from one and then end. Yes. Yeah. So this is what is a difference between your routing agent. So although we are using a router over here, but yeah, so this is how these things are different. And as you can see, so it is handing over to my billing department. Now, guys, so we are able to see everything, right? So which department, what was the question, and then like what is the response that it is trying to give, and then what is a log which is available inside my handoff. Now, moving to the next agent, which is eventually going to be the last agent, and that is a autonomous agent. So let's try to talk about autonomous agent. So autonomous, as its name suggests, it must be able to do something on its own. I mean, like it should do the entire job, entire task automatically, right? So we are going to basically like give some sort of a goal, and then it should call some sort of a action. It should like do observations, and then it should also decide that whether I'm able to complete my goal or not in autonomous mode, right? For example, if I'm creating something inside Euron system, so if I'm going to ask, okay, so like launch a course for a Python basic, so obviously it should go, it should find out that what and all things are tools are available, and then it should curate the entire curriculum. It should curate basically a name, a descriptions, what you will get, a teachers, everything, right? Pricing, everything. It should like curate, and then it must be able to launch each and everything. So that is kind of a autonomous agent that we can try to create. So let's go ahead and let's do it. And autonomous agents should not stop unless and until it is not going to exhaust a maximum number of a try or iteration, you can say, or task completion. So it can stop at 2 point, either maximum number of basically iteration is exhausted, or maybe it is able to complete the task. So in these two situations only it will be able to stop, otherwise it should not stop. So fine, guys, let's go ahead and let's try to do it. Yeah, let's try to create this one. So let's create a tool. They can stop after token get exhausted as well, right, sir? Oh, obviously, right. If you're going to shut down your system and then you will ask, like, will they get a stop? Obviously, it will get a stop. If token get exhausted, if you're going to crash the server, so in that case, because token is a brain, right? Brain for agent. Without that, it can't do anything. Okay, so here we are trying to create one, uh, function tool, basically look up the company. So what it does, look a demo company information. So data alpha. So alpha sales an AI learning platform for $12 a month. Beta sales a developer training $30 a month, and gammas provide the enterprise AI training. Okay, so basically it will. This is just a mock-up data I have created for alpha, beta, and gamma company. Let's say. Now what we'll do, so we can try to basically define the actions over here. So for actions, we are going to call agents, and obviously for that we have to define the output. So if anyone is going to ask a question, so it should do a lookup basically, and then it should do a finish. So this is basically like my identity classes I'm trying to create. Nothing much. Then class evaluate. So it is going to basically check whether goal is achieved or not. Boolean is the output. So again, this is just a validation class. So agent action and evaluation is just a validation class that we are trying to use it over here. And then there is another validation class, identity class. Validation class I'm trying to use, autonomous state, goal observation, iterate, finish, and answer. Okay, they are just a classes, right? Which I will be basically like using it. So let's try to create an LLM, right? LLM with a structured output, and agent action is something that we have defined. So agent action, so that this LLM will be able to decide so where I have to go and what I'm supposed to basically do, and then it can decide a next action basically. Now to decide a next action, right, I need a node. Without that I can't do it. So here is a decision node I'm trying to create. So decision node is going to take a current state, by the way, right, which is coming from where, which is coming from this one. Means you are going to send a message that I'm looking for this kind of a training. So obviously it is supposed to call some sort of a node, and that node is going to take a decision. So what kind of a decision? So action llm dot invoke. So fine, this one. Goal, so it will try to find out the goal, information collected, observation, and then it is having instruction that you can look into alpha, beta, and gamma, the one that we have already created, right? So here, so finish it, enough information exists. If action is equal to finish, in that case llm dot invoke, and then give the final answer, and return. Otherwise, right, otherwise do one thing. So lookup dot company invoke action, and then return observation. Okay. And basically it will keep on doing the iterations in this particular place, means it will keep on deciding the next action, and then next action, and then next action. Okay, fine. Now here, so we can try to set a maximum number of iterations. So if it is not able to decide, then obviously it should go and stop itself. Now here, so we can try to create basically a condition. So autonomous control, if a state is equal to finish, then it's done. If a state is iteration, uh, more than equal to or greater than equal to a maximum number of iteration, so again in that case it should force finished, otherwise continue. So this is just a condition. I'm saying that if it is finished, then done. Otherwise try for the maximum iterations, and then force finished it. Otherwise continue it. So these are the only condition which will arise in between, right? And then for a forced finish, so when we are trying to like force finish, so here we have to showcase a proper message to the user that why we are like terminating it. So basically we are just trying to like send this information, returning this information in case of a force finish. Okay, fine. So now these are the only thing which is required, guys. Now what I will do, I'll try to build my entire graph. Interesting part, last part. So builder and then autonomous state. Here we are trying to add a node, decide node, force finish node. That's it. Two node we have added, let's say. And then like it will come, and it will come to the decide, and then from decide, so it will try to call the autonomous control. Either it will continue or force finish. That's it. And then I'm trying to add a force finish edge over here. Now let me show you the graph. This is how my graph looks like. Hmm. So it is going to start, then it will come to a decide node, and then after taking a decision, maybe it will call a decision once again, basically. So this is the reason we have a loop over here. So it will continue, it will keep on doing it. If it is done, so in that case, if it is finished, in that case, it will come to the end. If iteration will be exhausted, then it will call to the force finished, and then also it is going to give you some sort of a output saying that the number of iteration got exhausted, and because of that, so I'm trying to finish this particular execution. So this is what is going to happen. Now let me test it. Let's call this one. So here we are trying to pass a goal, compare alpha, beta, and gamma, and recommend the cheapest learning platform. Yeah. So alpha, beta, and gamma is my dummy data, and yeah. So I'm just trying to call it and execute it. So fine, it is going to do a comparison, and so Alpha offers an AI learning platform for $20 a month. Beta provides development training. So this is the information. So visit training for $30. Gamma this one. Alpha is the cheapest learning platform at $20 per month. Recommendation: choose Alpha as the most affordable learning platform. Compare Alpha, Beta, and Gamma and recommend the cheapest. So yes, it is able to do it. And observation wise, Alpha sells an AI learning platform for $20 a month. Beta sells a developer training program for $30 a month, and Gamma do this one. Fine. So yes, it is able to give me, and it is able to complete itself. Now let me do one thing. So I'll call the same, but I'll change the question. So here, instead of doing this, so I'm looking for basically a chartered accountant syllabus, and I'm preparing for a chartered accountancy in India. So basically, I want you to give me a recommendation with respect to a chartered accountant best possible uh, syllabus, as well as which company is providing it. So this is my question basically, and I don't have this kind of information in alpha, beta, gamma. So basically, those companies I don't have any kind of a syllabus or anything for a charter accountancy. So let's see how it is going to behave and work. Okay, so I'll go and check the trace. Okay, so here you will be able to see that finished is equals to false. Yeah, finished is equals to false. So it is trying to do iteration, 5 iterations. So here finish is equals to input wise, I'm looking for this. Then output wise, the answer is for preparing a charter accountancy in India, the syllabus is governed by Institute of Charter Accountancy ICA. The course is divided into a three main levels. Overview of the CA syllabus: CA Foundation, CA Intermediate, CA Final, and recommended study material this recommendation this, and I should like study from this one. It has done iterations with alpha. So here you can see that it is coming to the decide node, then here it is coming to my LLMs, and then it is looking for the company. So company for which I have a information which is available. So here autonomous control, it is trying to take a decision, right? It is trying to basically take a decision over here. Then again coming here, look up for the company, autonomous control. Then decide, look up for the company, autonomous control. Then again decide, looking for the company, autonomous control. Decide, looking for the company, autonomous control. And then coming to the force finished, by the way. Then coming to this particular part. So as you can see, so every time it is looking for a company from our data. So 5 times, if you count it, so it is looking for a company. It has done a company lookup 5 times, and it is not able to find out anything which is relevant to my questions. So then what it is trying to do, so it is trying to call basically a forced finish, and then it is just trying to give an answer from its own knowledge base by using a GPT, right? By using a GPT, because these information 5 times it has tried. This is what I was trying to show you, that 5 times it has tried. But yeah, so when I'm trying to call a force finish, so even in force finish I'm trying to call a LLMs. Now, if you are going to remove, for example, the force finish node that you have created, force finish node you have created, you are giving a LLM. Now we reach the maximum iteration limit. This. Give the best answer possible. So this is something that I have mentioned over here. Now, if I'm going to change a system thought over here, that do not try to give me an answer from a public, basically, or from your pre-trained data. If answer is not available within my access or within my data set or within my inputs, so just say that you are not able to find out an answer. So let's say I have changed the nature of this entire things. Yeah, nature of this entire things I have changed. Now if I'll try to execute, now let's say let's go and let's try to check what it is trying to do. So can I say that this time my output has changed? Basically, the answer is I'm not able to find an answer based on the information provided. Yeah, fine. So again, it is looking for like this information 5 times, and yes, it is not able to find out that information in a 5 iterations. So it has exhausted the maximum number of iterations, and I have strictly said that you are not supposed to look from the public information or from the pre-trained information that you have. So it will not even look into that, and it will come back to me. Make sense, guys? The autonomous one. Philosophy is simple. I mean, like, we'll keep on doing iterations, and then how it is supposed to behave and work and give me the final output, that depends upon my own system prompt. So I can go and I can control that, the one which I'm doing it. Yeah. So this is, guys, your 10th agent. Yeah. So 10 agent we are able to understand. Now tomorrow what we are going to do. So tomorrow I'll be talking about evals, basically. Very important even from the interview perspective. People are going to crush you on that. everyone is going to ask you a question with respect to a RAG evaluation and then like a agentic evaluation. It's a very hot topic for anyone, right? Very hot topic for anyone to form a question and then ask you, and with related with respect to the work that you have done. So that is a topic which is going to happen tomorrow. I'll be talking about the evals, not just talking about evals. I'll be like showing you by building it, by configuring a evals in a code itself. Make sense, guys? Any question for me? Anyone? Hope all of us are able to understand the agent. So creating an agent is easy, right, guys? Yeah. If you're able to understand philosophically what agent is, how we can configure. So can I say that creation of agent is not a big deal? You can create, you can trace, you can understand, and what is going inside the agent, everything on a micro level, you will be able to understand. Yeah. Okay. So everyone is saying yes. Cool. So any question for me? Anyone? You can raise hand or maybe like you can put your question inside a chat. So fine, guys. If we don't have any kind of a question, then we'll rest our class for today. Tomorrow, same time, 1 p.m. IST. And yeah, last week when I discussed about the agent, so I have given you a task. Those tasks are very very good. Try to complete those tasks and try to explain those tasks. Believe me, in your entire life after that, you don't have to look back into the agent topic. You will be able to create it. Yeah. And thank you. So from next week, we'll be start the project building. First, RAG, agentic RAG and RAG, I'll teach you. Uh, Evals, basically, see, a couple of things are very important, and that is also mentioned inside your syllabus. If you'll go and check your syllabus. So, Super 30 syllabus, by the way. So, open portal and here planner. So, planner wise, see, this is important, right? This is important. So RAG, graph RAG, advanced RAG, hybrid search, re-ranking, citation. I'll try to discuss all of these topics basically. And then this one is agents, memory, and MCPs, right? Yeah, this is very important. This is very important. Then you can get into a project combining both of this. Agentic plus RAG plus solving a different problem. So let's finish this one and then we'll get back into a project. So the project aims is supposed to be the project that we are going to create is going to be a self-healing system. So anyone can just raise a things and then system will decide, system will take a decision, system will try to patch those issues or build a new feature and then push it to the production. So that is going to be a pure agentic controlled system. That is something that we are going to create. Same project will extend the last one that we were like doing it, right? So same project we are going to continue. And tasks are very interesting, sir. Yeah, just do those tasks, guys. Those agentic tasks. Purposely, I have given you those 5 tasks. I believe 5 tasks. Yeah, it was 5. So 5 tasks. Yeah, if you are going to build it, and again, I'll give you 5 tasks this week. So Monday, you will be able to see that inside your dashboard. Do that task, and believe me, you don't have to look back into agent for entire life. And doesn't matter who is going to bring what framework, you will be able to deal with all the frameworks. So you don't have to go after the framework learning, like learn this framework, that framework. No, you understand the agentic concept. Let any framework come into the picture, you will be able to build it. Same we will do with RAG, agentic, and MCPs and all those things, right? So it's not like just with the agent, but yeah, complete the task, guys. That's very very important, right? Very important. So fine. Tomorrow, like I said, evaluation I'm going to discuss, right? And then so on. Seems like transcript is not generating properly. Initially, it's blank audio. After 1 hour, 30 minutes, the transcript is generated. No, no, no. So basically, in our video system, what happens? So first of all, we try to basically transcribe our videos and we try to convert that into a secure format plus a multiple low bandwidth format to 1080p format. Once that is done, then we process a transcript. So first of all, you will be able to see the video and then you will be able to see a transcript after some time. Yeah. So that's how transcript works. So after video upload, you have to wait for couple of hours. After that, you know, let me check your batch, right? Your is my. So this was the so see transcript is there, but okay, you are saying that there is a issue. No, Let me check the timestamp. 1 hour. Yeah, for a whole duration, it has created the transcript. See, transcript is there, guys. You can use it. You can download it. We will be using our transcript in our fine tuning section. So we are going to use our transcript and then we are going to fine tune the entire model. Or we can try to even train model from the scratch. That is also possible. So that is basically next chapter. I think we'll be talking about it in a next month end, not now. Okay, yes, Viresh, go ahead with your question. What is your question? Yeah, Viresh, you have a question?
Hello.
Yes, yeah, Viresh.
I was talking about this transcript itself. If you go to the video of last week,
Okay,
initial 20 minutes or initial 1 hour minute is not there. Introduction to agents. I was talking
okay,
about that
okay. So let
transcript
me
and
check.
initial timer time. If you
Okay,
see
so installation
that one,
then we can do the next step.
starts at
Okay,
1 hour
got it,
41
got it, got it,
minutes.
got it, got it. Yeah, so just do one thing, Novides. Just raise one ticket because if you raise the one ticket, right, it will go to the technical team and even I'll keep check on that. Just quickly, say these things. I'll ask my team to solve it by Monday, reprocess the transcript part by Monday.
Okay, okay, sure.
Yeah.
Also,
Yeah.
sir, in iOS application,
Hmm.
we are not. Can we download this in the application itself and then watch it offline? I think that feature is still
That iOS I have already asked to make it available in the app, but I think team has already built it. They are facing certain issues with respect to publishing the app, so it is getting rejected again and again with the new feature. So iOS have changed their terms, and because of that, so we have already built it. I think 2 or 3 weeks back, but since last 2 3 weeks, so we are facing these issues. So I think it will be available as soon as App Store is going to publish it,
okay. Okay, sure.
and then you can
Even
download and then you will be able to test it.
yeah, yeah. Even this LMS access like task and then your notification, those are not
Actually, we
clearly.
have already built it, so everything is there, but yeah, so it's not published so far because of this iOS new policies. So
Okay,
once it will be done, I'm assuming that I'm very hopeful about it, that maybe by this week or next week, so we'll be able to publish it. Yeah.
got it, sir. Thank you.
Yeah, thanks. Are we going to build a self data AI analytics dashboard? That we can do. That's very easy, not a big deal. Okay, so fine, everyone. With that, thank you so much, guys. Focus on the task. Very important. Task is the only important thing. So if you're able to complete the task, believe me, you don't have to look back into that same topic again in your entire life. If you're not doing it, then yeah, I mean, back and forth. So fine with that. Thank you so much, everyone. Take care.